Our lesson for today is all about complex rational expressions. When we see complex rational expressions, it's a fractions that the numerator and denominator contains one or more fractions. And then when we simplify this one, we can find first the least common denominator, which we can have a cube, b cube. And then we multiply each numerator. We can have 1 over a positive 1 over b multiplied by the least common denominator of a cube, b cube. And then the denominator, we have 1 over a cube positive 1 over b cube multiplied by the least common denominator, which is e cube, b cube, which is equal to, we multiply first fractions by the least common denominator, so a cube b cube multiplied by 1 becomes a cube b cube divided by a becomes e squared. Remember b cube, this one. And then the second one, we can have to multiply the second fractions by the least common denominator, so we can have a cube b cube multiplied by 1 becomes a cube b cube divided by b, so the remaining is e cube b squared. And then from the denominator, we multiply each numerator from this one, so e cube b cube multiplied by 1 becomes a cube b cube divided by a cube, the remaining is b cube. Then from the second term of the fractions, from the denominator, we have to multiply by 1, so a cube b cube cancel out b cube, the remaining is e cube. So our next steps, we can factor this, e squared b squared b cube positive e cube b squared. So since this one is the difference, so we can have e squared b squared, then we can have quantity of this one, so we can have b, then because b times b squared becomes b cube, so then factor from the second term, we have a, since a times e squared becomes a cube, then b squared times 1 becomes b, so this is our factor. Then we factor also from the denominator, since this is a b cube plus e cube, we can use the formula of the difference of cubes, the sum of cubes, so we can have b positive a, b squared negative e, b positive e squared, and then we cancel the common factor, so we have a squared b squared and b squared negative a, b positive e squared. So this is our answer, is squared b squared b over b squared negative ab positive b squared. This is another way in simplifying complex rational expressions. This is another method. First, we need to find the least common denominator of each numerator, so we can have least common denominator of ab, and then we can find the least common denominator also of the denominator, which we can have a cube b cube. And then when we simplify this one, we multiply each fractions, which we can have ab, so ab divided by a becomes b, so 1 over b, we multiply 1 over b multiplied by b over b, positive ab divided by b is equal to a, so 1 over b, we have 1 over b multiplied by a over a. And then next, we have the denominator, we multiply each least common denominator by each fraction, so since e cube b cube divided by a cube is equal to b cube, so we multiply 1 over a cube times b cubed plus a cubed, b cubed divided by b cubed becomes a cubed, so 1 over b cubed multiplied by e cubed is equal to, and then this one we can multiply each term, so we can have 1 times b becomes b, and then our denominator we can have ab, and then 1 times a becomes a. Use the least common denominator, we have ab over 1 times b cubed becomes b cubed. We use the least common denominator, a cubed, b cubed plus 1 times a cubed becomes a cubed over a cubed, b cubed, and then it's equal to b of b plus a, and then since it is the same denominator, we can use ab, so we have ab, then b cubed plus e cubed over a cubed, b cubed. In dividing fractions, we can have the rows by flipping up the reciprocal of the denominator. First, we can have the factor of each expression, so we can have b positive b, since it is a lowest term already. We have b plus a over ab multiplied by the reciprocal of a cubed, b cubed. So this is, we can flip up, so this will be our numerator, a cubed, b cubed over b cubed plus a cubed. In the next step, since we have a denominator b cubed plus b cubed, we can factor each. So we have b plus a over a cubed, b cubed, we multiply this one over ab, we have ab, and then this is the formula of the difference of the sum of cubes, so we have b plus a, b squared negative ab, positive a squared is equal to, cancel out the common factor, so we have b positive a, and then a cubed divided by a becomes a squared, b cubed divided by b becomes b squared. We cancel out this b and a, and the remaining is, cancel out this one, we have 2 here, so the left is a squared, b squared, and then our denominator left is b squared negative ab positive a squared, and this is the answer. Let's have exercises number 1. X squared negative y squared over xy over x minus y over y. And then first, before we simplify this one, we first factor the numerator from the first fractions. We have x squared negative y squared, so when we factor this one, we can use the formula of the difference of squares. We have x negative y, x positive y. This is the factor over xy, and then copy this one, x negative y over y, because it is already factored. So we can, by using this one, as we know that roles in dividing fractions, we can flip up by the reciprocal. So we can have x negative y, x positive y over xy multiplied by the reciprocal, which we can have y over x negative y. And then we multiply this one by combining together. We have y, quantity of x negative y, quantity of x positive y over x y, quantity of x negative y. And then we cancel out the common factor. We have y, cancel out, then x negative y, and the remaining is x positive y over x, and this is our answer, x positive y over x. And then let's have example number 2. We have x over y minus y over x over y over y minus 1 over x. So simply we can find the least common denominator of each fraction. So we can have, from the numerator we have xy, and the least common denominator from the denominator is xy also. So they have xy divided by y becomes x, so x times x, we can divide each numerator and denominator by x, and then minus y over x multiplied by x, y divided by x becomes y. So we can multiply each numerator and the denominator by y. In this one we have x, so we multiply each numerator and denominator by x, plus 1 over x, and then xy divided by x becomes y, so we'll multiply each numerator and denominator by y, and then we multiply. We have x times x becomes x squared over xy. We have the LCD, and then y times y becomes y squared over xy, and then under the denominator we have 1 over y times x becomes x over xy, then y times 1 becomes y over xy, and then we have x squared negative y squared. We have the denominator of xy over x plus y over xy. Next we do is we factor x squared negative y squared, so we can use the formula of the different squares. So we have x positive y, x negative y over xy over x plus y over xy. And next we can have to divide in dividing complex fractions. We can use the rules of dividing fractions. We can flip up by using the reciprocal. So we have x positive y, quantity of x negative y over xy, multiplied by the reciprocal of x plus y over xy becomes, we flip up this one, so we have xy over x plus y, and then we cancel out the common factor, so we have xy, and then we have x plus y, cancel out this one, the remaining is x negative y over 1, since there is always a factor over here, and x minus y. This is the answer, x minus y. Then let's have a look at our example number 3. We have a over 1 negative a plus 1 positive a over 1 negative a over a plus a 1 positive a. And then first we can find the least common denominator from the numerator. So our least common denominator is a quantity 1 negative a, and then first we multiply each numerator by a quantity 1 negative a. So we have, when we divide this one by 1 negative a, the result is a. Therefore we multiply each first fractions of a, and then from the second fractions we have to multiply the, when we divide this one, the remaining is 1 negative a, so we multiply each numerator and denominator by 1 negative a. So we have, and then the denominator, we have also the least common denominator is different from the numerator. We have a quantity 1 positive a, and then when we simplify this one, we multiply its numerator and denominator by 1 positive a over 1 positive a, and then the second fractions we have a over 1 plus a, 1 positive a, we multiply its numerator and denominator by a, so we have a, and then we multiply its numerator first in the first fractions, we multiply this together, and then the other fractions, but we have an LCD is the same. We have a quantity 1 negative a, so a times a becomes a squared, and then copy the least common denominator, which is a quantity 1 negative a, and then in the second fractions we have 1 positive a. You can use the quantity when we multiply, no need to multiply together, you only copy the factors and then the least common denominator. And then in the second fractions we have 1 negative a times 1 positive a, we only use the close and open parentheses, and then a quantity 1 positive a, and then the second fractions we have a squared over a 1 positive a. You can use the close parentheses, which is, you can use the parentheses here, don't forget. And then when we simplify this one in divisions, we can flip up the reciprocal. So in the denominator we can have a quantity 1 negative a, and then a squared. We can copy this one, positive 1 positive a quantity, this one, and quantity 1 negative a over 1 negative a 1 positive a. We have the denominator is a quantity 1 positive 1, and then we can copy only this one, so we have 1 negative a, 1 negative a quantity, and quantity 1 positive a plus a squared. This is all together. And then when we simplify this one, we can flip up the denominator by using the reciprocal. So we can copy this a squared positive 1 positive a quantity 1 negative a over a quantity 1 negative a multiplied by the reciprocal of the denominator. So we have a quantity 1 positive a over 1 negative a quantity 1 positive a positive, so this is positive. And then when we simplify this one, cancel out the common factors. So we have common factor here, this one cancel out, 1 negative a cancel out, and a we cancel out also, and the remaining is 1 positive a over 1 negative a, and this is our answer. Let's have another example number 1. We have 1 over a squared positive 2 over ab plus 1 over b squared over 1 over a squared negative 1b squared. And then first we can find the least common denominator and we multiply its fractions. When we have least common denominator is a squared b squared, so we can multiply by each fraction. So we have 1 over a squared positive 2 over ab positive 1 over b squared. We multiply each fractions by a squared b squared, and then in the denominator we have 1 over a squared negative 1b squared. We multiply also this one by the least common denominator a squared b squared. So we multiply each by first fractions. So we have a squared b squared times 1 becomes a squared b squared divide a squared. The remaining is b squared. Positive a squared b squared multiplied by 2 becomes 2 a squared b squared divide ab becomes 2ab. And then a squared b squared multiplied by 1 becomes a squared b squared divided by b squared. The remaining is a squared. And then on the denominator we have a squared b squared multiplied by 1 divided by a squared becomes b squared. Then a squared b squared multiplied by 1 becomes a squared b squared divide b squared. The remaining is a squared. And then in this we can factor by using the trial and error method in the trinomial, as you can see my last video on the factoring the trinomial by using the trial and error. So we have b positive a and b positive a, because ab becomes ab, a plus a times b becomes ab, so ab plus ab becomes 2ab, and this is our factor from the numerator. And then from the denominator we can use the formula of the difference of squares. So we have b positive a and b negative a, and then we cancel out the common factor, so the remaining is b positive a over b negative A, and this is the answer. And then let's have another example, number 5. We have c positive 8c squared over 1 positive 2c. So we can use the least common denominator. Our least common denominator is c squared. So we have c squared, so we multiply each fractions including the whole number. Our whole number is letter c, so we have c squared, and in the denominator also we can multiply by the least common denominator by c, and then we have c multiplied by c becomes c cubed, then c squared times 8 becomes 8c squared by c squared, so the remaining is 8, and then the denominator we have c squared, then 2c squared divided c becomes 2c. This one is 2c, and then this one we can factor by using the difference of the sum of cubes. So we have c positive 2, and then c plus 2 becomes c squared negative 2c positive 4. Remember our last video when we factor by the difference of cubes or sum of cubes? You check it out, and then we cancel out the common factor. We have c positive squared, the remaining is c squared negative 2c positive 4 over c, and this is our answer. That's all.